Whenever you hear about a massive data breach, Facebook users compromised, Instagram credentials leaked, millions of accounts sold on the dark web, you might feel a sense of relief if you understand basic security. You know passwords are not stored in plain text. Companies hash them. So even if the database gets stolen, your actual password is safe, right? That is exactly where the misunderstanding creates the risk. Welcome back to Tech Sky. We are diving into password cracking, how attackers recover passwords from stolen databases and encrypted files. You will learn why password hashing does not guarantee safety, how dictionary attacks work, how brute force systematically breaks passwords, and what actually makes a password secure. Before we begin, I need to make something absolutely clear. Everything demonstrated in this video is strictly for educational purposes only. The knowledge you are about to gain comes with significant responsibility. Password cracking tools are powerful for security research, penetration testing, and auditing your own security. However, using these techniques against files or accounts you do not own or have explicit authorization to test is not only unethical, but illegal in many jurisdictions. All demonstrations use only files we create and own. So let's address that false sense of security. Open your terminal and make sure your system is updated. Type sudo apt update to refresh package lists, then sudo apt upgrade to install available updates. This ensures all our tools work correctly. Now we need a file to protect. Type echo tech sky confidential data greater than secret.txt to create a text file with sensitive content. You can see the file is created, but it is not secured. Anyone with access to this file can read its contents freely. To protect it, we will put it in a zip archive with password encryption. Type zip_encrypt, protected.zip, secret.txt, and press enter. It prompts for a password. We are setting a simple 6-character password here. Type ABC123, then confirm it. The file is now encrypted inside the zip archive. Try to unzip or open it, and you cannot without the password. Our secret file is protected. Now here is where password cracking begins. Encrypted files store password hashes, not the actual passwords. To crack the password, we first need to extract that hash. Type zip2john, protected.zip, greater than, zip_hash.txt, and press enter. John the Ripper, the tool we just used, supports many file formats for hash extraction. Zip files, PDF documents, Office files, RAR archives, encrypted SSH keys, KeePass databases, and dozens more. Each file type has its own extraction command. Since we are working with zip, we used zip2john. Open the hash file. You can see a long, unreadable string. This is the password hash extracted from the encrypted zip file. This hash is useless until we discover what password created it. And that is exactly what we are about to do. The first method we will use is called a dictionary attack. Instead of randomly guessing passwords, this method uses pre-built word lists containing millions of common passwords, previously breached passwords, keyboard patterns, and variations. Attackers maintain massive collections of these word lists. Some contain billions of entries compiled from real data breaches over decades. Kali Linux provides several word lists by default. Type ls/usr/share/wordlists to see available lists. You can see multiple word lists, but the most famous is rockyou.txt. This word list contains over 14 million real passwords from an actual data breach. It is the standard for password cracking demonstrations and penetration testing. Before we can use it, we need to extract it from its compressed format. Type sudo gzip-d, followed by the rockyou.txt.gz file path in the wordlist directory, and press enter. The file extracts and is now ready to use. Now we launch the dictionary attack. Type johnzip_hash.txt /wordlist =usr/share /wordlists/rockyou.txt and press enter. Watch what happens. Look at that. Password cracked. John the Ripper tested millions of passwords per second from the word list, hashed each one, compared it to our extracted hash, and found the match. The password was ABC123, which appears near the beginning of the rockyou word list, because it is an extremely common password. You can verify the cracked password anytime by typing john-show zip_hash.txt. It displays the recovered password clearly. Now understand something critical. This attack totally depends on your word list, the hash algorithm type, and the encryption strength. If the password is not in your word list, the dictionary attack fails completely. If the file uses strong encryption, cracking takes significantly longer. Weak encryption like old zip crypto cracks in seconds. Strong AES 256 encryption takes exponentially more time for each password guess. Dictionary attacks are fast but limited. They only work if the password exists in your word list. What happens when it does not? Let us test that scenario. Remove the protected zip file and the hash file. Now encrypt the secret file again, with a new password that definitely is not in any word list. Type the same zip command, but this time, use the password x2f3h. A random 5-character string. Extract the hash again, using the same zip2 john command. Now run the dictionary attack against this new hash. Watch closely. John the Ripper searches through the entire rockyou word list. 14 million password attempts. And finds nothing. The attack fails. If you run John Show now, it reveals nothing. The password was not in the word list, so the dictionary attack is useless. This is where brute force comes in. Unlike dictionary attacks that use pre-built lists, brute force systematically generates and tests every possible password combination within defined parameters. You are not guessing randomly. You are making informed assumptions about the password based on the target. For example, if the target frequently works with files and needs quick access, they probably set a short password. Maybe 4 to 5 characters. Likely lowercase letters and numbers for simplicity. No special characters or uppercase because those are harder to type quickly. We design our brute force attack around that scenario. Type johnzip_hash.txt _incremental equals lower num min-length equals 4 max-length equals 5. Let me explain what this does. The incremental mode uses brute force. Lower num means only lowercase letters and numbers. Min-length 4 and max-length 5 restrict the search to 4 or 5 character passwords. And there it is. Password cracked. Our dictionary attack failed completely, but brute force succeeded because we correctly predicted the password pattern. This is how real password cracking works. Dictionary attacks for speed against common passwords. Brute force for targeted attacks when you understand the password creation patterns. So how do you protect yourself? First, length matters more than complexity. A 16-character password of random words is stronger than an 8-character password with symbols. Why? Because the number of possible combinations grows exponentially with each additional character. Second, use truly random passwords. Not patterns. Not variations of dictionary words. Not personal information. Use a password manager to generate and store cryptographically random passwords. Third, understand that file encryption is only as strong as the password protecting it. AES 256 encryption is unbreakable with current technology. But if your password is ABC123, the encryption is worthless. Fourth, for sensitive files, use passphrases instead of passwords. 4 or 5 random words create passwords that are both strong and memorable. Correct horse battery staple is infinitely stronger than password 123. Finally, enable additional encryption layers when possible. Encrypt the entire drive with BitLocker on Windows or Lux on Linux. Use encrypted containers with VeraCrypt. File-level encryption is your last line of defense, not your only one. If you found this demonstration valuable, hit that like button and hype the video. Subscribe and turn on notifications so you never miss a security tutorial. Share this with someone who still thinks their 8-character password is secure. In the comments, tell me what topic I should cover next. Until then, this is Tech Sky, your ultimate battleground of cybersecurity and ethical hacking.